Hello and good evening. Welcome to this EAA Retrofit training event. My name is Alex Little. I'm your stand-in chair for this evening. Christina Gager, who should be the chair, is running a little bit late and hopes to be with us for the Q&A session towards the end of the event. But for just now, I'm going to introduce the event and our speakers. And I should start by explaining the inspiration for this event is the need to reduce the amount of CO2 in the atmosphere to mitigate global warming. Around about 80% of the UK CO2 emissions are from buildings. UK lags behind many of our continental neighbours in the introduction of insulation to reduce carbon emissions, and many UK architects don't have the skill sets to specify retrofit insulation well. So this event is to explore ways in which this knowledge can be gained. So a deep retrofit where significant improvements are made can be complex, and works have to be done well to ensure insulation is effective. PAS 2035 provides a framework for organizational retrofit work, and the Retrofit Coordinator role is well suited to architects. From the Retrofit Academy, we have David Pierpoint, its founder and chief executive. The Retrofit Academy is a not-for-profit training company dedicated to improving the capabilities of the UK retrofit sector. Their main focus is on the role of the Retrofit Coordinator as defined by PAS 2035. Insulating traditional walls internally is technically challenging and can be problematic. Specification of too much insulation can cause condensation within the walls. Hydrothermal analysis can determine the appropriate levels of insulation for a particular wall construction. From the Technical University of Dublin, we have Joseph Little, who is Assistant Head of the School of Dublin School of Architecture. His areas of research include energy efficiency, renovation of modern and traditional buildings, hydrothermal risk evaluation as a key tool in guiding specifications and design for low risk and high performance. To make meaningful carbon reductions in the heating of buildings, we have to make significant reductions in the heat loss through the building envelope. The Passivhaus standard is hard to achieve in existing buildings, but the NRPHIT standard, which follows the same thinking, can be applied to existing buildings. And from the Passivhaus Trust, we have John Palmer, Research and Policy Director. John has recently authored Passivhaus, The Route to Zero Carbon, exploring how zero carbon targets relate to fabric efficiency in buildings. John is a certified Passivhaus consultant, SAP assessor, and experienced project manager. So a couple of housekeeping points. This event is being recorded and will be posted on the EAA YouTube channel after the event. And we will, of course, be taking questions after the speakers have spoken. And if you could drop your questions in the chat box, we will review them and pick through them for the speakers on conclusion of the three talks. So 3 speakers are going to speak for around 20 minutes each. It might run on a bit. And we'll start with David, moving on to Joseph, and then John Palmer at the end. So I'm going to hand over now to David Pierpoint to tell us a little bit about the Retrofit Academy.
Thank you very much. Lovely to meet you all, and it's very flattering to be invited and to be in such esteemed company. I'll try not to take the whole of those 20 minutes because, you know, let's face it, most of us haven't had tea yet, so I'll try and save us a bit of time. But I'm going to talk to you about the Level 5 Diploma in Retrofit Coordination and Risk Management, but also about setting the scene in terms of the PAS 2035 standard. Our mission as an organisation is to put the PAS into practice. You know, put the 2035 in the middle of it. Put the PAS 2035 into practice doesn't sound quite as catchy as putting the PAS into practice. That's what we're all about, really. To the extent that our technical director is Dr. Peter Rickaby, who was the technical author of that standard. So we've been living and breathing it for many years now. In fact, many years before it was even published. And I'll give you a bit of that backstory as we go through. What are we? We're the Independent National Centre of Excellence for Domestic Retrofit. We are entirely self-proclaimed. No one has given us that title. We call it ourselves, and we did that because we support a membership of about 150 organisations and people, the vast majority of whom, well, all of whom are trying to do exactly what we're doing, helping to put the PAS into practice. So they're on that journey with us. So we just figured that was a neat way of describing what we do. Talked about that mission. We work very closely with stakeholders in I mean, it's the whole of the UK in theory, but you know, Trustmark and the Department for Business, Energy and Industrial Strategy down in London. So we're quite, I suppose, quite England focused. We do train quite a lot of people in Scotland actually, but one of the things I've been asked to speak about is how those standards are or aren't being applied elsewhere in the UK. So I'll come on to that. Now, we are just in the process of developing our second qualification, which is very much an entry-level qualification in understanding domestic retrofit. So it's a very exciting time. It's happening at breakneck speed. But come next month, we will be delivering this brand new course in understanding domestic retrofit. It's far too basic for the vast majority of people who be on this course, so it's not really one for you guys. But for this army of retrofitters we need to carry out the work, both existing trades and people outside the industry who've perhaps lost their work because of COVID and want to come into the space, that's a very relevant sort of entry-level qualification. Well, what we're best known for at the Retrofit Academy is this Retrofit Coordinator piece. And we're best known for it because it was a group of us, including myself and Peter, who sat in a room about 10 years ago and came up with that phrase. Long before it was a British standard around retrofit was even a twinkle in Peter's eye. But it was a role that's off the back of a program called Retrofit for the Future, which was a technology strategy board program to find out how to do deep retrofit effectively in social housing. And it was very noticeable that the projects that had performed as they should have done and best were those that had an individual in charge of them who was pulling everything together. And it was out of that that understanding that we conceived of the role of Retrofit Coordinator, mainly a group of architects, it has to be said. Now, the reason any of this is necessary is these horrible things I'm putting on screen here. Said to my fellow speakers, I hope they haven't got the same pictures of the poor detailing and the damp patches. And depressingly having to state that these are all, of course, post-retrofit, not pre-retrofit. So you're going to hear a lot more from Joseph in particular about why these are issues. Depressingly, these are incredibly common. And what I always say when giving presentations like this is, if you haven't noticed before, drive around any council estate that's had a reasonable amount of retrofit work done on it, and you will see many of these things. You will see what were bright yellow walls a few years ago slowly turning black, and it's thoroughly depressing. So that's why we have a need for this standard. Now, I hope you'll just indulge me for a couple of minutes here. I'm going to show you a short video. It's only a couple of minutes worth. This is actually the trailer to something we created called PAS 2035, the movie. And we used this last autumn to, well, we used the whole movie, but this trailer was used to promote a series of clinics we ran with local authorities who have been given a lot of money by government at the minute to invest into retrofit projects. So I think it tells its own story, and we'll revisit it in a second.
Faced with the challenge of a generation, two local authority officers and their contractor have a meeting. At stake, should they adopt PAS 2035 or not? A story of memos, a story of funding, regulations, and concerns about the cost of compliance. About embracing change and building trust. Will they make the leap in the unknown or stick to what they know? Will they ventilate or prevaricate?
I just can't understand it. We had such high hopes for this lad scheme. We spent £20 million trying to improve people's homes, but the chief exec's inbox is crammed full of letters of complaint. It's going to cost us millions to put right. Crag Hall is a disaster.
It's a load of red tape. Look, Bill, it's optional, and I would avoid it like the plague.
But what is it? Just made my head spin. So much jargon, unintended this, interrestrial that, or something, I don't know. And ventilation the other, load of hot air. They told me I should aim to enerfit with an energy sprung. I mean, ooh.
To be honest, I thought it made a lot of sense. Well, I did say that we needed to apply past 2035 at our planning meeting before we started, but you said no.
2035, it's a load of flowcharts and processes, but it's just too complicated. It's not what energy efficiency is all about, Bill.
Their fault, we'll blame them.
Wow.
The guys will never wear it. It's all too academic.
Well, and where does that get us, Bill? And that's the bad habit we've got to wean ourselves off of, Bill.
It sounds like he's lost control. We can blame them.
I mean, what's that quote? You know, the definition of insanity is doing the same thing over again and expecting a different result, something like that.
Get Sean on here and we'll get to the bottom of it.
PAS 2035, the movie. It's the biggest film event of the year featuring interstitial condensation.
I'll spare you the credits, but yeah, I think you get the gist. And it was the biggest film event of the year featuring interstitial condensation. I don't think there was much competition. Okay, so the whole point of those clinics was trying to simplify and break down this very complicated British standard into a number of 6 simple steps. Often we're guilty as a sector, the sort of green or eco sector, we're guilty of making really quite simple things sound very complicated. And of course, all these local authority officers who are going to be put in charge of tens of millions of pounds in many cases, they know nothing about retrofit by their own admission. That we asked them before the clinics, 0. So a lot of money's been put in their care and they've been asked to apply a standard they got no understanding of. So we just try and keep it as simple as we possibly can. Now, the flowchart you see on the screen there is a work of genius. That's by Peter Rickaby. It's in PAS 2035. And we break it down into 6 simple steps. So the first of those is defining what you're trying to achieve for a project at the start and making sure you make a log of those so that at the end you can check if you've done not get signs, is it? The second step is considering various aspects of that project and determining how risky it is. It's an obvious thing to do too, isn't it? We do that on new build all the time. We do all of this on new build all the time, by the way. We just, as an industry in retrofit and energy efficiency, haven't done it this way before. This is the controversial bit. This is the crazy idea that before we spend a lot of money on someone's home, we might want to understand it. Okay, so it's moving away from a very shallow 20 to 30 minute energy assessment, as we might call them, to a whole dwelling assessment that might take up to half a day or even a full day. Very controversial that. Someone got to pay for it, you know. And then this bit, which is where many of you as architects fit into the planning and design. Well, I can assure you that in terms of energy efficiency and energy company obligation projects, there's been no planning or design put into any of those projects, and yet billions of pounds have been spent on them. So that is a new bit, and you know, not before time. Installation and handover. Installation is sort of where projects in the past have begun and ended. So, you know, we do stuff to a building, leads to a load of problems. We don't think about what we're doing to it. And then we walk away from it and leave the resident with the problems and the pictures that I showed you at the start. And then the final step, which is all about monitoring and evaluating it. Doesn't need to be a complicated process. If you've done the project well, it's a simple survey, and it's going to tell you that you've done what you set out to do. Hey presto, and if it doesn't, then someone has to sort it out. So it's a very simple 6-stage process. I won't go through the detail of that today. It's a couple of hours worth to do that. But astride it like a colossus is this person. This is Joy, our retrofit coordinator. And it's Joy whose job it is to apply this standard. PAS 2035 introduces 6 roles that are to be fulfilled on every retrofit project. Some of them are fairly light touch. So a retrofit advisor, their job is to give some good advice at the beginning of a project normally. A retrofit installer, it's their job to carry out the work. A retrofit designer, it's their job to do the design work. An assessor to carry out the energy assessment, the building assessment. An evaluator at the end of it to make sure it's done what it's meant to do. And then there's retrofit coordinator character, who links everything together, and I'll explain how. Now, PAS 2035 says that they are a specialist retrofit project manager who take overall responsibility for overseeing the assessment of dwellings, the identification, specification, and evaluation of energy efficiency measures in accordance with PAS 2035, right? So it's their neck on the line. It's their professional responsibility. There is an ethos that underpins that, and that is that they act on behalf of the public and the client's interests. So now that is a challenge, to say the least, and it suggests that there's a degree of independence about a retrofit coordinator, which we'll revisit in a second or two. Now this slide tells you who can do what. Who can do what on a PAS 2035 compliant project. So on the left-hand side there, you've got levels of risk. We talked about the risk assessment. We triage risk as either being low, medium, and high, and that determines how specialist a team we need in order to carry the work out. And all I want you to take away from this very complicated slide is that we've got effectively square pegs in square holes by and large, or was it round pegs and round holes? And the retrofit coordinator is sort of everywhere. They're either doing strategy, for example, or they are able to carry out individual other areas if they're appropriately qualified. And they're overseeing the bits that they're not involved in. So they're sort of everywhere. Very, very important. Now, this conflict of interest issue is something that comes up a lot. And as I was talking to all these local authorities, I was encouraging them to think about how they would manage that conflict of interest. Their default position, as you might expect, was, well, we don't know what we're doing, we'll outsource it. We'll outsource it all. Let's find a contractor. That's what they do. It's what local authorities do, isn't it? They procure services. So I was asking them to think about what was right for them and whether there was that conflict of interest. Because if your retrofit coordinator also happens to work for the installer, it's debatable whether that is a neutral and independent position. Now, the PAS doesn't require them to be independent, but there's a clear, this public interest point is very important. So that stimulated a lot of thought, I think. I also told them that there were probably increasing levels of expertise and cost. So, at the lower end of the cost, and in many cases, not what I'm generalizing here, but this installer employed coordinator is probably going to be the cheapest of the options. A domestic energy assessor who's upskilled to be a coordinator, their fees aren't terribly high. So there are quite a lot of those sorts of people. And then there's many of you as chartered professionals for whom this role was first conceived. It should be stressed, who really know what you're doing, but you are a bit more expensive because you're in university for 5 years and all that sort of good stuff. And then there's these very, very specialist people in areas like vulnerable and traditional buildings, but we won't get hung up on them. And then we talked to them about local authority employees themselves becoming retrofit coordinators. So chartered surveyors, architects, and the like who work for local authorities. And we felt that that was a really good option where it was viable. Okay, so that's the role. That's the information about the PAS. I'm just going to give you one slide's worth on the retrofit coordinator diploma itself before I hand over. So this is it's a regulated qualification. The awarding body there, the Open College Network West Midlands, that's who you get your certificate from, and they're regulated by Ofqual, which means we're kept on the straight and narrow. The Retrofit Academy is the only provider of this qualification, and we developed the qualification and know it inside out. It is required by PAS 2035. So there's a section in there that says every project needs to have a retrofit coordinator, and it says that every retrofit coordinator must hold this qualification. And as the only provider of it, I can tell you that we've got around about 800 people enrolled onto it at the moment, and we have 230 or so graduates. So our objective was that by the end of this year, we'd have 1,000, hopefully in practice, not just in training. So a long way to go, but we're sort of making good progress. Now, we've a long way. It started off as an excellent course that you all the theory you possibly need to know about moisture risk and thermal performance and building fabric improvement, fabric first approaches and whole house retrofit and all these other wonderful things that you need to know about, the building physics and so on. What we've done over the last 12 months is add into that a whole load of in-practice stuff. Now that there is we've had retrofit coordinators qualified for over a year, and they got out of qualification, started to try and do it, and they sort of said to us, what's next? So we thought, okay, we've got lots more work to do here. So we've developed lots of tools and resources and guidance that we now also take these retrofit coordinators through. What you're seeing on the screen here is one of the templates we use. This is actually the risk assessment piece in our template. So we're training people to use that and do the job as well as just a theory now. Within the course, there are 12 modules and 12 sets of assessment. Quite extensive amounts of study and assessment involved. It takes around about 150 hours in total. So in many ways, it's the equivalent of 1 unit of a university degree, that sort of level. And at level 5, it is, sort of at that sort of academic level too. You're seeing a few examples of the course materials here. There's a huge archive that we've developed. It's literally thousands and thousands of slides, assignments, case studies. It's been a labour of love for nearly a decade now, and we're continuing to add to it. We are now running the program so that as a learner goes through the e-learning course, they're also attending seminars as they go, all of which are expert led. So Dr. Rickaby and Alan Pither and Bob Pruitt and Sarah Price and other well-known people in the industry are delivering those seminars in sort of hour to hour and a half long sessions. A lot of those are the practical stuff. All candidates also have to take part in a detailed case study and then present their findings of that case study to one of our tutors. So it's not just a case of completing written assignments, they have to complete a case study too. It takes 150 hours. And then once they've graduated, as we found, we've changed our model here, they need a lot of support in practice. So they join our Centre of Excellence for 12 months as part of what they do. This is the model we're moving to right now, actually. And they get to work with us for a full year. They may want to stay longer, and they can choose to sort of do that if they want to. So all in all, this is, it's very comprehensive, and we're beginning to get good numbers of retrofit coordinator into practice and lodging projects successfully. So it's going quite well. Now, I'll just finish by mentioning that we bid into something called the Green Home Grant Skills and Training Competition late last year, and we've secured English government, UK government funding to put 120 people through this course on a fully funded basis, as in there's no cost to the learner. Now, frustratingly, for those of you in Scotland, that's only available to people working in England. So you can be based in Scotland, but you have to show that you do at least some work in England. The other slight fly in the ointment there is that if you want to apply for that, you'll need to visit our website in the next 24 hours and fill in the application form, because the closing deadline is actually tomorrow, well, midnight tomorrow. But you're very welcome to apply. Equally, you're very welcome if the timings of that don't suit, if it doesn't work, whatever, to take the course yourself as normal. Just finished. There's some good resources on our website which are freely available. There's a guide to PAS 2035 to download, and also PAS 2035 compliance maps, which sort of lays out what an individual will do step by step. So you can download those from our website at your leisure. Thank you very much. I hope I haven't gone too much over time. I'll answer any of these questions in the chat.
Yeah, we'll field questions as we go along, David. Is Alex there? Alex, do you want to?
Well, actually, I was hoping to do the questions at the end. So.
All right. Yeah. No. Of course. Sorry, my mistake.
If Joseph is around, we could move on to the next section. Joseph, are you there?
Yes, I am. And I was just putting a final touch to my presentation. 1 second. There. Okay. So I have just done something there. And I am willing to share. So I'm going to start my video and turn to that. And let's see if this all works. Share screen. And I think, 1 second, let me start this. I'll move that over there. I'll share screen, turn this on here. And I will share screen over. Share screen, 1 second. That should be that screen. That's screen 1. I want screen 3. Where's screen 3? Oh, there's screen 3. Apologies. Yep, they're across the top. In Teams, they run the screens across the top, and in
getting an insight to your complex computer situation.
Yeah. And in Zoom, they run top to bottom. Okay, so
we can see that. That's all good.
That's great, and you can see me as well.
Yeah.
Because I've lost sight of you just for the moment. How do I get you back again? Oh yeah, I can do that. Kind of great. Okay, so that's kind of reassuring. So guys, I've got a few too many slides. Like David, I'd like to allow us all to have a nice lunch, or sorry, nice dinner. But I'll just get going. So I am Joseph Little. I am an assistant head of school in the Dublin School of Architecture, which is within Technological University Dublin. And some of you may be familiar with the old DIT, Dublin Institute of Technology, which has supplied architectural technologists in particular to building design offices across the UK for decades. And a Bolton Street grad was considered to be quite a good architect. We also have obviously architecture programs. We've building performance masters, which is what I'm the program chair of and manager. And right now I'm in my hempcrete studio at the bottom of my garden. So as you're probably in the bottom of your gardens are your box bedrooms and all that too. Anyway, so here we are. We've got the banana that you can slip on, and it's all about risk. You're having a great run, but what happens if you fall, and did you have your eyes open? So kind of very basic stuff that David was talking about earlier on. And so much of what we need to deal with is that kind of basic stuff, taking the right steps. So we're about to massive, we're in the middle of, or still in the process of launching, I think probably a generationally significant campaign to try and get our carbon emissions down. I would say it also means that people need to actually be content with lower temperatures, where I've retrofitted buildings in the past where I then monitor the clients in the year or two afterwards, and they happily had temperatures at 24 degrees, which wiped out, every single good thing that I was trying to do with their with the energy efficiency retrofit. So just looking at Europe very quickly, you happen to live in the country, and you probably know this, which has the overall oldest building stock, I think, in the world. And there are areas which are even older, such as there you can see lowlands of Scotland and most of Wales and so on. If you compare it to Ireland, where I'm calling from, funnily enough, we have, I think, ourselves and Cyprus have the youngest building stock in Europe. So despite the fact that Dublin, let's say, has a big Georgian core, and so does Limerick, and Cork has some fine Victorian buildings and so on, if you look at the broad swathe of even Dublin, but then of course you move into all of the rest of the country, we are a very, very young country in terms of building quality. And I think it shows. We don't have the charm sometimes I think that your wonderful villages and towns have. But that's a challenge for you. We have a lot of solid walls. You have an extraordinary number of solid walls, and so on. If you look at very briefly from some European document, well, this is McKenzie looking at what is there and what needs to be retrofitted and when, what buildings will be added and when, what homes. You can see that you have no matter how we talk about new build, the big issue is clearly and evidently a retrofit project for existing buildings. So you could say it's nowhere as important in the world, but certainly in Europe, as it is here in the UK for you to deal with this as a country. I mean, you can see Silesia or parts of southern Germany or parts of the Auvergne in France, wherever, have extraordinary amounts in this as well. But as a country as a whole, you have an extraordinary challenge. You need to get it right. We know that the complexity of buildings, particularly when we talk about solid wall, is significant. We can talk about, we're familiar with those heat transfer mechanisms, conduction, convection, not so much with radiation. And then we move to the mechanisms of moisture transfer within our walls. And most of us talk to some extent about vapor diffusion, how vapor moves through as a gas through those porous linked structures. And then convection is about kind of air gaps. So it's moving through the air and it can be moving at speed. And of course, that air is carrying moisture with it. But what we don't talk so much about is capillary action and surface diffusion. So capillary action, where literally the straw or the pore, to use an analogy, is fully filled and liquid water can move really quite fast through it. And then surface diffusion, where that, again, to use the analogy, straw is lined with liquid, but there's also vapor moving through as well. And you can have liquid water moving in one direction and vapor moving in another direction. You can have moisture, as we call it, as a solid, as a gas, and as a liquid in the same wall at the same time, and even the same portions of moisture changing states through the same day. And places like Scotland, west of Scotland particularly, and Wales and most of Ireland, where there's extremely high and consistent relative humidities, drying is a really big issue. So it's not so much the heavy rainfall. In fact, parts of Italy have much higher rainfalls than Dublin, let's say. But what we have in many places in this western seaboard of the British Isles is this fairly consistently elevated relative humidity. And whereas David was saying before, that outside surface of that wall was able to dry out, partly because the sun hit it, radiant heat, but was also gaining from the heating effect of the day, of the heating system within the building, actually helping to dry out that wall. It would be 2 or 3 degrees higher, warmer than the outside temperatures in many times over the heating season. When you insulate that well, that capacity isn't there for that drying to happen from within. So we need to be much more careful about then the aesthetic effects. And a retrofit that looks ugly or looks dirty or black, no matter how healthy it is actually for the people inside and how much heat is retained, is not going to be perceived well by the community. But then even worse, when we see those images again David showed of that black mold or these other different conditions, respiratory conditions inside, it can become shocking, and it can collapse a government, it can collapse a movement, and it can damage either the passive house movement, the retrofit movement, all these sorts of things. If somebody can say, that retrofit project made my Johnny sick, and that story is multiplied, we're in trouble. So it's really, really important in so many ways that we get it right. And then there's the question of the heritage of the built environment and the quality of those buildings themselves. So there's lots of different concerns we need to think about. And we don't know enough as an industry, certainly building design professionals, about how our buildings are made and what those different mechanisms that affect things are. And a major issue that we want to look at is to ensure that the drying capacity is always elevated above the wetting capacity. And that can be done. Now, I remember several years ago at this stage, looking at a website when I was giving a talk, I think in Scotland the next day, and I came across, in Glasgow, I came across this particular presentation where some community website was very, very proud of the installation work that had been grant aided by your government and that they were carrying out and were very, very proud of, to such an extent they were showing it on their website. And of course, this just looks scary. You've got polythene wrapped mineral wool. You've got foil where maybe foil doesn't make sense. You've got air paths moving around. You've got no understanding of what's going on. You've got nothing consistent. This is an experiment. It may have some value. Actually, it's so bad, it may actually not be too bad from a moisture perspective, but it won't achieve what it was meant to achieve. And it's a waste of people's money and so on. We also have that big thing of societal need. And again, this is a slightly old quote. To meet carbon budgets, a further 6 to 7 million cavities, 7 million lofts, and 1 million solid walls need to be insulated by 2020. That's, that was the ambition. 6 years ago. How much of that has been achieved in the last 6 years? I'd say very little of it. Obviously, the Green Deal collapsed since then and other things, but it collapsed because there was a lack of credibility. There was a lack of safety. There was a lack of an awareness. There were a great deal of accountants involved in that and lawyers, but not a great deal of technical people. And, you know, I'm not going to read all this out, but the question, the implicit assumption behind all this, that all these wonderful people in the Energy Saving Trust and the World, I would say the World Wrestling Federation, but the World Wildlife Fund, the Forum for the Future, Greenpeace, all these great people saying we need to do this right. And we agree, we building professionals agree, but their implicit assumption is that we have adequate information about the solid walls, that we know the right assessment methods, that the right specifiers are in place and the completed work will always be good. That's the assumption. So, you know, there are not, you know, we know very well, even then, some of us, that there were naive assumptions, but what can we learn and how can we get it right? So, you know, one of the things we could do is understand a little bit more about risk. You know, what's the most risky thing you'll do today? It's probably getting out of bed. You could walk across the road. There's a big difference between risk and hazard as well. You could walk across the road many, many times with your eyes closed. I wouldn't recommend it. And you may well live several of those times, but it's very likely that eventually you will be hit. So the hazard is dying because you are being injured because you've been hit by the vehicle. The risk is the likelihood of that happening and the significance if it does happen. Now they're different, hazard and risk. If we look at a very simple chart from the American Army, you can see that, you know, in 3 of the 4 cases we're looking at here, where the consequences are grave or minor, where the uncertainty is little or much, when to do risk evaluation, and this includes walking across the road. All those different kind of measures. And really, it's only when there's little uncertainty and a minor risk that no risk analysis is required, you know, the bottom right hand corner there. But in every other situation, the appropriate level of risk is necessary. And that really means that, you know, in 3 of those cases, we should be absolutely engaging formally in that process, having an awareness of what we're doing. And then obviously top left there, we're moving into a case where we really need to take that further. So, you know, it's that classic thing. Do you know where you are? The amount of times I've talked to architects or even manufacturers of building materials that don't actually understand that they've got out of their site boots, or they've got out of their fine leather shoes or something, and they're now in space boots and they're floating somewhere above the planet in the level of risk that they're taking, where they've gone beyond standards, codes of practice. There's no trade body. There's actually potentially very little standard body of information there. There may be no case law. And these guys are floating out in the outer space, doing this project, not realizing that if anything goes wrong in that project, they have no support whatsoever. Why would you do that? Why would you do that? Anyway, so I would say in terms of understanding risk, it's funny, it's unlike thermal modeling or maybe even passive house, we don't need to know an exact value. We don't need to know that it's you know, the risk is 3.123 or as opposed to 3.562. But we need to know where we are on the landscape of risk. We need to know that we're not in the top left-hand corner with weapons of mass destruction, or top right-hand corner with extreme weather, or further down with illicit trade. You know, to use this kind of loose analogy from the World Economic Forum, we really need to know. We really need to know where we are. We don't need to know. Sorry, I probably said that the wrong way around. We need to know broadly where we are on that landscape and the actions that we need to take. But we don't need to know, are we here or here or here? But we do need to know where we are in this landscape. So it's about understanding and the reason I say it that way is because there's so much uncertainty. Some of that imposed by the government, by, let's say, not giving us climate files that we can use for simulation. Some of it imposed by the building standards of the builder that are yet to come. Some of it imposed by our lack of understanding. Some of it imposed by the weather on that day of installation, you know, et cetera, et cetera. What's a really important thing to understand is the difference between accuracy and precision. And a lot of people say, well, same, but actually they're really different. And one of the things we need to know is, working in a context of uncertainty, is that the robustness of how we approach a project, a risk assessment, is accurate, even accepting that the precision is low. So on the right-hand dartboard, somebody has got this wonderful false confidence that they know exactly what they're doing, and they're going to push out several different risk assessments and say, this is what it is, and look how confident I can be and how wonderful it is, and let's proceed. So that's a false. It's from their ignorance. It's from their lack of knowledge. It's because the information they were given maybe was incorrect, but they didn't know it. You know, lots of different things could happen. But if you look at the guy on the left, that as we get more information, as we go further with PAS standards and the government gives us information, or we evaluate more historic building materials, or so on and so forth, the precision will come closer and closer and closer. But what's incredibly important is that we're starting from a position which is defensible, robust, and as accurate as possible. And that does require training. So it's not for the retrofit coordinator on site, it is for the building design professional to engage with. So as it happens, there is loads of guidance. Before about 2011, it was a desert to some extent. But if you looked at what's been done by the SGBA, if you look at the Knowledge Guidance Wheel, Responsible Retrofit, the Bristolian Guide, which is so wonderful, the guide that I pushed out myself with my colleagues Benny Athareggi and Kalina Ferraro before I came into TU Dublin, which was written in a context of uncertainty for Scotland, with a Stonewall tenement in question. Other things, Colin King looking at uncertain consequences, unintended consequences, looking at Sanders and May's wonderful document, God bless Neil May. Obviously, I don't know if you know, you probably don't, I don't, some of you may not know him, but he was a bit of a mentor for me, and he died a few years ago, but he was the lead author in this and so many of the other documents on the page. And then other documents from a kind of conservation perspective. It's interesting to see PAS 2035 is referencing BS 7913, which is from 2013, but not referencing, from what I can see, BS EN 16883, which is more recent from 2017, Conservation of Cultural Heritage Guidelines for Improving the Energy Performance of Historic Buildings. I think that's a pretty good one to be looking at. So there's that kind of guidance is not regulatory, but it's really sober guidance. And what's really important is all of it comes from a building physics perspective, an applied building physics perspective, not for the physicist, but for the design professional who needs to understand this sufficiently. And these documents are all coming at it from the same way. And the reason I say that is the previous generation of documents in many cases weren't. And you had guidance which was coming from only the dew point method or the Glaser method, saying it's always right to have a vapor barrier, or the more insulation the better, or comments like this which had no sense of limits or boundary conditions. So this kind of guidance is quite coherent, even though it's coming from different people, which is great. Then you've got other guidance, obviously in the UK context. BS 5250 is going to be revised. There's a draft copy out at the moment, which is good to see. Significant rewriting of the code of practice, which was for control of condensation, but of course the new one is quite rightly about control of moisture in buildings, which is a much bigger topic. And then PAS 2035, you saw some of David's the logic pathway that Peter has come out, Rickaby has come out with, and so on, which is really interesting stuff. So, in that context of pathways, kind of following from that, if you look at the bottom left-hand corner there, you've got PAS 2035, and there's that question, the specifier is at the table saying, what do I do? What's safe? What's reasonable? And where do I look? So I imagine you might look at approved document C, or you might look at PAS 2035 and so on. You might go across to various documents such as BS 5250. At the moment, 2016 is the latest version, 2019's draft, but that might point you at different types of risk assessment. And you could say there's 4 different types. What I should say is simplified is not a simplified version of full. Simplified is talking about dew point or Glaser. It could say chalk, and full could say cheese. And in some cases, they could both say camembert and whatever brie. So you can't say one is a simplification of the other. But at least in the 2016 edition, for the first time, they actually said that there were 4 different methods you could use. And in air dominated, by the way, all desktop risk assessments are abandoned, because actually none of them capture the significance of what's going on. So there's guidance where it's prescriptive, and that will always be necessary, and it can be very good when it's used within its limits. The Glaser method under BSEN 13788 is excellent. For years, I was very critical of it, but I've actually come to realize it's excellent when it's used in the context of the scope, which is on page 4 of the document, and it's limited. So use it within the limits and it's fine. The problem was, since about the 1920s, the only risk assessment methods in the building industry were the dew point method, which had all its limits. Those limits weren't fully understood, and it was used for everything. And that's the problem. It's still being used far too widely, still being used way beyond scope, and too many designers still do not read that document and establish on page 4 the scope. So there's a thing. 15026 came out in 2007, but it was only referenced by BS 5250 in 2016. So there was, whatever the maths is, there was 7 years where there was a lack, or sorry, maths is bad, 9 years, where there were buildings being built where the builder was saying, or was saying, we're building according to BS 5250, or even the material supplier was saying, we're were assessing the product in accordance with BS 5250. And that was cheeky because this standard existed, but it wasn't properly signposted in BS 5250 in that period, and people could therefore get away with it where a building design professional didn't know this themselves. So at least that's now been much corrected. And then finally, prescriptive, again, are you into computational fluid dynamics and so on. So this is kind of the signposts for specification that you need to be very aware of. And you don't always need to go with, I'm going to talk about WFI, yes, but you don't always need to go with WFI. You need to go with the right method, the appropriate method within scope that meets the timing and whatever else that you have. But if you need to go with, let's say, WFI or dynamic, that's what you need to do. You need to do something that you can stand over. So the Glaser method, I won't talk a lot about these things. It's about the charting the temperature profile, the saturation profile, and then the actual quantity of moisture present and so on. Where they touch, you've got liquid water, Tauwasser in German. So that used to be done on a slide, literally on a drawing board, and dots were charted and literally lines were drawn. It went back to that kind of really sensible, robust, but very limited assessment. It's a calculation, it's not a simulation. That's important. You now can, under BS or ISEN 15026, carry out, I wouldn't say it's a simulation, it's a numerical, sorry, it's not a dynamic simulation, it's a numerical simulation. So it's a calculation for every time step. And you can set up different cases very quickly. You can see on the red area of that brick wall there, monitoring positions being introduced. You can throw things around very quickly. You can introduce your own material files. I'm showing you a screenshot of WFI, but Delphin is a bit more complicated, but is also validated to that standard. It allows you to take account of things like, go back, sorry, if I can. It allows you to take account of the orientation, the inclination, different climate events, local climate issues. It allows you to take account of failure. So, there's a break in a window reveal wall seal. What happens if, a certain amount of driving rain gets in there? What happens if the air tightness membrane isn't perfect? All those sorts of imperfections and conditions, construction moisture on the day that the racking board was laid, or, whatever, all those things you can actually allow for and assess parametrically. Compare that to the dew point method, and I love this example, which is a bit mean, but you've got I think, is it Lerwick in the Shetland Islands, in the north of Scotland. If you took a Glaser method or a dew point method calculation and you looked at a building with high internal occupancy, it could be shown that a wall made of 2 layers of plasterboard, plasterboard with 350 millimeters of mineral wool. So this is silly, I know this is silly. Will actually pass a Glaser method calculation if it has a VCL on the room side. And that's because a Glaser method calculation only takes account of the moisture from inside. It takes no account whatsoever of the moisture outside, other than its relative humidity outside. Rainfall does not exist in a Glaser method calculation. Radiant sunshine does not exist in a Glaser calculation. Only ambient conditions in temperature and humidity, and then obviously the conditions with the conditions within that material buildup itself. So that's not valuable, that's not useful, that's dangerous. To be able to say to somebody that that's going to be a safe buildup when clearly it's a dreadful buildup and will collapse. Just to kind of prove that, I'm using a bit of software. It happens to be built as SKU. Like I said, it works fine when it's used within its limits. There's a dwelling with high occupancy. There's Lerwick at the top of the screen. There's the external or the boundary conditions, internal and external. There's the wall assembly, all properly chosen according to those material characteristics. There's the risk assessment. There's no moisture accumulation. The bar you're seeing horizontal at the bottom of the screen there shows a position for every month, and it shows there's no moisture accumulation, therefore there's no drying. This is perfectly safe. As far as that calculation is telling you, no condensation is predicted at any interface in any month. And that's coming, computer says yes, computer says no. It's nonsense, but it's actually used every day by most people doing most risk assessment in the British Isles. So going back to the WFI interface, there's an awful lot of things you can do with that. There, like I said, the project cases, the graphical display, the hygrothermal values, the hygrothermal functions. So a function is something that changes with time or changes with how relative humidity affects moisture content, how temperature could affect the thermal conductivity, all these different sorts of conditions that have a sort of dynamic characteristic. So you can look at all that. Like I said, about inclination and orientation and exposure, all those things can be mapped. it's also important to be aware that there's a wide range of material characteristics. Building materials vary. They can vary from the same quarry, but let's take that out of it. They could be widely different in terms, let's say, of their moisture storage function, which is a huge capacity, that and let's say the water absorption rate. So how quickly does it wick in water during that rainfall event, let's say, and what's the capacity of that fabric to store that moisture? There's just two characteristics. You can see the variety of values in measured materials. It's so important that we get UK materials measured in this next period. And actually there is, I think Professor Hugh Banfill Philip Banfill, isn't it, is doing a study at the moment for Historic Environment Scotland, where he's doing some measurements like this for Scottish materials, which is great, but we need a lot more of that kind of thing. Here's just a silly example of comparing the pink dots in the Glaser method, where it's talking about internal temperature, which is always 20 degrees, never changes, compared to, let's say, an assessment under EN 15026, where you can see that solar heat gain, internal heat gain is possible, and we know that's real. And my God, is that important? And it's going to become increasingly important over the years. We need to understand these things. So again, you're using assessment methods which takes count of some level of reality. It's not computational fluid dynamics. It's not reality. It's a simplified version of reality, but hopefully it's sufficiently close that you can do good things. So here's a very quick case study. I'm probably beginning to run out of time. This is available in the link at the bottom of the page there, but basically we took measurements, physical measurements, using the Karsten tube of a particular very common red brick, one brick thick red brick house in a place called Ranelagh in South Dublin. We looked at the original condition that it might have been when it was built in 1905, the condition it was in when we met it, when we saw it, and the typical retrofit that would get grant aid, and then another retrofit which we felt would be also well insulated, but would bring it back to a better level of moisture management. So I'm not going to talk about the details. We were using foamed glass aggregate as our proposal and trying to keep very much a moisture open kind of insulation strategy. The physical measurements, you can see the green, the dark green line represents the level of moisture uptake using a Karsten tube that we measured, and you could see the other measurements that we took. The ones in colour represent a particular study that we were doing for Dublin City Council. The grey lines represent other measurements in general of walls in Dublin. And you can see very high absorption walls at the top, the grey and red and orange lines. You can see lower levels of absorption for bricks further down with the grey and the two greens, the other greys. And then you can move into rendered walls and stone walls and so on. And it's incredibly important to know where is your, let's say your wall. I could also talk about roofs and so on, but where is that fabric in that context? It's, you might be able to get away with something in the Nile Street project, which could be absolutely fine, which in Lennox Street would be reasonably high risk and maybe it should be avoided. And in Henrietta Street could result in evident failure within a very short time. I mean, where are you on that table? We were to, having done the physical measurement, we were able to select values in the database, in the WFI database, which is expanding and is really large, that best represented the measured values. So we were starting with something in a hypothetical desktop study, which was at least linked in one of the highest levels of risk, in this case, water absorptivity, to reality and that particular building. And that study on that wall, by the way, took 1 hour. And maybe there was a bit of an hour, graphing something in Excel afterwards. So well achievable, and then feeding that in the right way, in a robust way, into a parametric study. WFI, I won't go into the whole thing. This is WFI 2D, which is more complex, but there's a whole dynamic time step. So for every step, two equations are solved against each other, and then you move to the next cell and the next time step, and some of the inputs from the new time step is from the outputs of the last time step, and so on and so forth, on your cells going from inside to outside in these equations. So they're numerically heavy, and they really only became possible when processors became cheap and so on in the last 20 years. Where we looked at that particular wall, you could see, and this is just a moment in time, and black represents very, very wet. Red represents really quite dry, really low relative humidities, or like 60%, in fact, relatively low relative humidity. And just even visually, if you let it wash over you, if you look at the original condition during a rainwater driving rain event, during a drying out period, and during the driest period we could find over the final year in a 3 or 4 year simulation, you can see that the moisture is always greater at the bottom. You can see that the wall has the ability to dry out, and there is a process going on, and it takes some months. It's not necessarily a quick process, and the middle of the wall can be wetter. And if you look at the current condition where they tanked the inside face and they put in cement pointing instead of the lime pointing, and they put in a DPM where they blocked moisture from drying into the room, into the floor from the base of the wall, you can see that the current condition has a somewhat elevated risk compared to the original, where the original had a suspended timber floor. And if I move on further, the one on the left, guys, the 3 lines on the left is the one that attracts the mainstream retrofit grant. So what we're grant aiding, what our tax money is paying for, is the one on the left. Compare that to the original, compare that to the current condition, and compare that to the one I'm proposing on the right as a better compromise. But it's the one on the left that gets the grant aid at the moment in Ireland, let's say. And then the one on the left we're proposing, take out the tanking, take out the DPM, replace the line pointing, put in a capillary open insulation strategy that's fully bonded, and put in the foam glass aggregate with the limecrete slab and so on below that, and let's see what happens. And it's still elevated. It is now warmer, and you know, retrofit does raise risks, but these risks are much more appropriate than the left condition, which is the kind of just slap the stuff on, don't talk about it approach. And then if we're looking at that particular black spot you're looking at in the 4 different graphs on the left, 4 different images on the left, you can see that the blue line is what we had there. So at that particular junction, which a thermal modeler would immediately zone in on, you can see that we had a much lower relative humidity there in blue. And the condition I'm proposing as an improvement that's also renovated, that's also insulated, is the green. So it's quite a bit more elevated. It's quite a bit more, it's quite a bit higher, but at least there is some level of drying going on. And for reasons I won't bore you with now, that could still be okay. And it's to do with moisture storage functions and so on. But if you look at the red line, you can actually see that you're into conditions, you're moving from 97% into 99% relative humidity on an ongoing basis. And it's very problematic. So this is the kind of value that you begin to kind of see these things, begin to make these kind of judgments. So upskilling for building design professionals. I've only put these slides together quickly, so apologies if they're a bit rough. But I've been offering with the Fraunhofer Institute for Building Physics that invented the WFI software in the first place, and we're lead authors in the standard and so on. They're key people in Europe. We teach what's normally a 2-day, full-day event with the Green Register for Building Professionals every year. Sometimes we've done that in Bristol, sometimes London. In the past, I taught in Leeds and Glasgow and so on. And this year we did that online on the 20th of November 2020. We taught for 3 webinar events over an 8-day period. We taught online, and it was the first time we'd done that, and it allowed us to have people from around the world. And it's still giving you a good insight into specifically the use of WFI. So it was limited to that, but it also brought in an element of the building physics, the risks, all these sorts of things, and it got people started in the space of sober risk evaluation. This offering here, the CPD certificate in hydrothermal risk assessment, is an academic qualification. It takes place over 6 weeks. It's 100 learning hours. It's still for building design professionals. It's online. It's very flexible in terms of when you're engaging. There's webinars and so on. I'll show you in a moment a little bit more about that. And that started last Friday, so it's just gone. And Alex actually went from the 8-day event with us, Alex Little, who's hosting this event, and is now attending the 6-week event with us. But in this, we really test people's learning and bring them further and hopefully give them confidence. There's lots of feedback. There's lots of formative exercises. They're using the software. They're getting an understanding. But it also is broader because we teach people Glazer in this. We also teach as well as WFI, and we've a chance and time to teach more consistently and significantly in the subject. And I think, as you'll see, at €600, it's actually quite cheap, and you get the software for 9 months. So that is something that's available pretty much at this time every year. And then the last thing I would say, and you can see the link on the website. You can see the DIT website is still there. We're in transition between the old DIT structures and resources and the TU Dublin ones. The last thing I just show is this. I think it's the second last slide. We also have, so we have also have a CPT certificate in building energy modeling using PHPP, which we're just starting to roll out in May. And I'm not sure if it's yet the 7th or the 14th of May, but that'll have the same 6-week structure I described. And that we're able to offer that to the UK building design professionals because of a collaborative partnership that we've entered with AECB just before Christmas, the Association for Environment Conscious Building. And we're very excited about that. I think they're very excited about that. I know there's some great teaching going on by different people in the UK, but I don't think the academic and the more robust and longer kind of engagement is there. And you can see from the graph below, I hope you can kind of work it out. Maybe it's a little bit confusing to see it for the first time, but we have a process where each week we release, for the first 4 weeks, we release 3 hours of lecturing content that with a formative exercise, literally as homework for people to kind of explore and learn. They then have a webinar where there's feedback. They get feedback on that and have a good discussion about it. And then that pattern happens 4 times. And there's a graded multiple choice questionnaire, which is an examinable element in the 2 red lines you can see there. On the 2nd and the 4th Thursdays. The brief for a project is introduced somewhere along that pathway. And then in the 5th week, you get to submit maybe a half complete, 2/3 complete draft project. And you get a chance to get additional feedback in a workshop, an afternoon workshop on that, and then make your final submission a week later. So we're nursing you along and giving you largely complete documents initially, like a PHPP file or a WFI file and so on. Initially, we're getting you into it, we're getting you playing around, we're then giving you feedback, and then increasingly we're allowing you to become more independent. And then by the time you're in the project, it's a blank sheet and you're starting from the beginning, but you've gone through enough engagement and feedback that you can hopefully do that in a robust way. We don't claim that you're competent at the end, but we do claim that you're solidly on the path towards competence. And I think that's a very good place to be. So that's actually 2 offerings, one relating to what Alex asked me to talk about, the hydrothermal risk assessment bit, but then another one which relates to the next speaker in the context of PHPP and Enerfit and so on. So thank you very much. It's been a pleasure.
Right. Joseph, thank you very much. I can't actually share my screen at the moment. Alice?
Do you see the green?
Yeah, it
What's
says
at the very bottom?
host disabled, participant share screen sharing.
Oh.
I think.
Try that now, John. Yeah.
Yeah, that's fine.
Sorry about that.
There we go. So hopefully everybody can see that.
Yeah, that looks good.
Great. Okay. Good evening, everybody. Really great to be here. And I've actually honor really to be sharing the stage with 2 previous speakers who are who've given us some great overviews of different ends of the topic, really. I hope Joseph hasn't scared you too much with what can go wrong. And what I'm going to do now is sort of go specifically in a little bit into Passivhaus, but also a little bit about the big picture about retrofit, which both David and Joseph have touched on a little. So what I'm going to do is talk about where we are now to start with, the big picture, if you like, then a little bit about Passivhaus. And then moving on to what Enerfit is, which is the retrofit version of Passivhaus, and then finishing off with just a few slides on how far we need to go with retrofit and what the numbers are telling us at the moment. So this slide shows you where we are with greenhouse gas emissions from buildings in the UK. You can get charts that look really good in terms of our emissions from building, but if you take out the effect of decarbonising the grid, this is what you get. So you can see that we've actually flatlined over pretty much the last 10 years in terms of making our buildings more efficient. And this is a version of a slide that Joseph showed, which just shows you that the challenge is not getting new buildings up to good standards, it's the buildings we've already got. So the new builds actually is a sideshow when it comes to emissions. We really need to look at the existing stock. And this is the work we've done recently in conjunction with Letty, which is quite an interesting way of looking at the breakdown of that stock. And suddenly you can see that there are some sort of sacred cows that disappear. So everybody says, what about all those Victorian terraces? We couldn't possibly retrofit all those. Well, actually, we haven't got that many Victorian terraces in the grand scheme of things. What we have got is a lot of semi-detached, a lot of post-war properties, and a lot of properties with uninsulated and cavities and solid walls as well. So that kind of just puts the overall picture into context. Yes, we've got a lot of heritage buildings, but we've got a lot which aren't as well. But even in the unconstrained, if you like, the non-heritage features building, there will be ones where we're going to need to do, adopt a sensitive approach to retrofit. So what is Passivhaus? Well, I haven't got time to go through it in detail, and I'm sure many of you are familiar with it, but really it's this approach, which is you can keep your coffee warm on your hot plate, or you can keep it warm in your insulated carafe. And if you keep it on your hot plate, you need to pump energy through it constantly. So that's the principle, is keep the energy in rather than having to put lots of energy into to compensate with what you're losing. In a typical UK home, we've got a situation like this where we've got all those losses through various parts of the building fabric, floors, walls, etc. And then we've got gains of solar energy and internal gains, things we do, cooking, washing within the building. And then the sort of purplish bit is what's left. And that's what your heating system has to provide. And in a typical new build in the UK, including a performance gap, we think it's around 85 kilowatt hours per meter squared per year. What a passive house does, this is a new build passive house, is squashes down those losses, and I've left the scale the same here, which means that if your solar and your internal gains stay approximately the same, the heating demand comes down to something really, really small, and that's has to be 15 or less for the passive house standard, and that's the kind of magic number we try and get to. But there are also some other criteria which are not necessarily related purely to energy, and you can see here that passive house is also a comfort standard, and this is really important because many people I know who live in passive houses who started their journey from an energy efficiency point of view, the first thing they say when you talk to them about their passive house is how great it is to live in terms of air quality, warm temperatures, or comfortable temperatures the whole year round, just great living environment, and that's where a lot of these criteria have come from. And what we also need to consider is that there's the way all this fits together. So we've got these criteria, which I've just shown you. These lead to some effects, which is no condensation and mold, no external pollutants, or very limited external pollutants, because all your air coming in is being filtered, and your internal air is also being removed and taken outside. So internal pollutants disappear as well. So we get these warm, comfortable buildings with healthy indoor air quality, which are comfortable in summer, which is in contrast with what we often get, even in new build, but particularly in our older building stock, is cold homes, fuel poverty with people unable or can't afford to heat rooms, and really poor indoor air quality. And which also on the other side of that, we've got discomfort in summer, which is a significant risk to particularly old and young. So building a passive house, I'm going to talk very briefly about these topics. Let's start off with form factor. So form factor is really the efficiency of shape of our building. So we've got a building here, which is a single-story bungalow, floor area of 93 meters squared, but lots of heat loss area, 280 meters squared, as opposed to an apartment, which has got the same amount of usable floor area, but it's got 4 times less, or slightly less than 4 times less heat loss area. Now, yes, the flat above will have a heat loss roof, the flat below heat loss floor, but overall, the efficiency of a multi-story compact shape means that your insulation, your fabric has to work less hard. So the top building there, we're going to have to put 4 times as much insulation in there just to get to the same levels of performance. So you're making the job hard for yourself before you even start with a very poor form factor. And this just illustrates that. So on the far hand side, right hand side, you can see that single story odd shaped buildings have form factors of about 4 to 4.5. Multi-story compact down at the other end, down as low perhaps as 0.7. And the figures in brackets next to it are the level of a rough guide as to the level of insulation of a typical mineral wool type performance, thickness of insulation that you'd need in those buildings. So you can see that passive house gets, to attain passive house. So passive house gets really difficult in our core form factor buildings with 400 mil of insulation, whereas up at the other end, it's almost the same as building regs. So form factor is really key to get that right before you even start, and it makes everything else easier. The other key point is orientation. So these two, form factor orientation, aren't really anything about passive house specifically. They just make the job easier because they make things more efficient. So what you're seeing here is the blue bars in the background are the space heating demand for the building. So you can see we start at just below 15. And we've taken this particular apartment and just rotated it through the compass. We haven't changed the insulation, we haven't changed anything else. What we've actually done effectively is reoriented the glazing, and the glazing is the important part here because glazing will lose you heat but also gain you heat. So if we optimize it, as we have done in the first one, south facing, then we're at just under 15. By the time we've turned that building around, we're up at 25. So we've not far away from double the heat loss from that building. So again, if we get our glazing orientation wrong, it makes things difficult for ourselves. Moving on to what you might think the obvious part of passive houses, continuous insulation. We obviously want a good amount of insulation. We typically allow for a total construction thickness of 500 mil to start with for a passive house in the UK. And we want to wrap the whole building in this too, Kirsty. And you would be amazed how often that doesn't happen in typical construction. There are weak points, there are gaps. And in particular, you can see there's gaps where the structure penetrates the insulation there. And what we need to do is eliminate those. And those are our thermal bridges, where there are discontinuities in the insulation layer. They are in all buildings, but by the time you get to passive house levels of insulation, they have a major effect. And they can also lead to some of the things that Joseph was showing earlier, which is condensation and mold, because they've got very low surface temperatures. So in passive house, we try and design them out, get rid of them from the start, rather than compensate for them. We also need good quality glazing. So as I say, glazing is a double-edged sword. It lets solar gain in, but it also lets heat out, and it can also let too much solar gain in and lead to overheating situations. So for the UK, we will, in a passive house situation, we'll use triple glazing, because that gives us a much higher level of performance in terms of heat retention. We'll also probably have some kind of shading to address the overheating risk. We need our buildings to be airtight. This is for a couple of reasons. It's to go for the comfort angle in terms of no drafts, and it's also from an energy point of view, because we don't want cold air coming into the building, which is displacing the warm air that we've heated up. So 0.6 air changes per hour at 50 pascals is the passive house standard, which is roughly about 10 times or more better than the building regs average of, or what people design to, of around 5. And finally, we've made our building airtight. That's great from a comfort and an energy point of view, but not good from an air quality point of view. So what we then need to do is put in a mechanical ventilation system, which will constantly extract our stale and humid air and constantly supply fresh air. So this is one of the, I've got one of these in my house. It's fantastic. What it does is gives you brilliant indoor air quality without the penalty of having to open your windows to get that. So it's good for health, but it's also good for energy as well. So that's a very, very quick run through the principles of passive house. What is Enefit? Well, Enefit is a derivation of passive house. It's for retrofit, but it allows for some of the things that you're going to be stuck with when it comes to retrofit. So the first thing you're going to be stuck with is form factor. So that's kind of out the window. You can't really change that in an existing building very easily unless you're doing some sort of extension. You also can't change your orientation. And your thermal bridging, in most cases, you're going to be stuck with some of it. Some of it you can fix, some of it you can't. But we can still deal with insulation, we can still deal with air tightness, and we can still deal with ventilation. So the Enefit criteria, here I've put them against the passive house new build criteria, and you can see that you get a bit of an allowance on air tightness, so you can go slightly more, and you get an allowance on heating demand, and that heating demand, rather than being 15, is either 20, 25 or 30, and that depends which climate zone you are in the UK. I'll explain what they are in a moment, but we've actually got 3 separate climate zones in the UK. So that's the heating demand method, and And that's still quite hard. So people say that the Passivhaus standard is quite hard to achieve. It is, and I won't make any excuse for that. It's probably the highest fabric standard that there is, and the Enefit side of it is also quite hard to achieve. And there are certain situations where your form factor, your orientation, the amount of glazing is going to work against you so much that these levels of heat demand are actually possibly unachievable. And in those cases, there is the Enefit component approach, which is slightly misnamed because it's actually an elemental approach. And for those three climate zones, cold, cool temperate, and warm temperate, what you've then got is elemental fabric U values, window U values, and ventilation performance levels. You've also in the background got that thermal bridge. Thermal bridge is still assessed, and you've also got the requirement that your internal temperatures stay above 17 degrees to avoid condensation and mold and improve comfort. But what this allows you to do is in those situations where a heat demand method is not going to work, you can still go for the component method. And these are the climate zones, and you can see that if you're down in the south west, then you've got a bit of an easy ride with a warm temperate climate, but up in Scotland it's going to be more difficult because there's a big chunk of the cold climate zone. So just a couple of case studies just to illustrate how this might work in practice. We've got here Zetland Road, which is in Manchester, which is a Victorian villa, semi-detached, sorry, 1884. And here there's a great emphasis here on natural and vapor open materials. The installation strategy in this case, it was a completely new inner leaf using timber eye joist and blown cellulose, U value right down to 0.116 in some cases, and there you can see the level of performance that was achieved. 0.9 air changes per hour, annual heat demand below the 15 at 12, and a heat load of just 11 watts per meter squared. This is a slightly different project. So again, mid-19th century, but this on the terrace. Solid wall, concrete floor, and flat timber roof. Slightly unusual roof situation. Here is a more, you can see the materials used here are not so natural, more of your fossil fuel oriented, high performance, possibly because there's more space constraints inside the building. So aerogel to the front walls, getting us down to 0.16. EPS, external EWI at the rear, and polyurethane installation and under the floor. Performance again, 0.8, so under the 1 required for Enefit. 23, so that was under our retrofit standard of 25 for this particular part of the world, and heating load down 11. And also I just want to mention that it's not just individual buildings or smaller buildings. There is several large-scale Enefit retrofits been undertaken. Cedar Court in Glasgow and Ernley Close in Manchester, and you can see that the overall energy demand in both cases was sort of between 70 to 80% reduction from where we started from with both those buildings. So just to finish off, I just wanted to kind of put it into context and talk about how far we need to go with retrofit. Obviously, Passivhaus and Enefit is kind of the gold standard. Can we afford to go there? Do we need to go there? Well, there are some questions here, some of which remain a little bit unanswered as to what governs how far we go with retrofit. So we want to get to net zero, that's great. But to get to net zero, there is only a finite amount of renewable energy in the future. So in 2050, we will only have a certain amount of renewable energy. Will that be enough to offset the energy we're going to use in our buildings? Question mark. Perhaps that might not be the limiting factor. The limiting factor might be our peak load. We are going to have to move all our energy demand, most of which is currently gas for thermal energy for our heating and hot water, onto the electricity grid. Via heat pumps, but still there's going to be a significant demand there. Is there going to be enough peak load from all our renewable energy sources and the storage devices in order to deliver that? Perhaps that's the constraining factor. We want to reduce bills, and is there a payback? Does that start to drive retrofit? Can we get the cost of retrofit down and the desire of people to reduce their bills down? Does that drive it? Cost to the nation. Every kilowatt costs money, and what I mean by that is you can either pay to save a kilowatt hour, you can put more insulation in your building and save a kilowatt hour, or If you don't do that, you're still going to use that kilowatt hour, which means it has to be generated. And it has to be generated by a wind farm or a solar panel, and they all cost money. And by the way, they all have to be replaced every 20 years, whereas your insulation stays in place for the lifetime of the building. So what's more effective? What's the cost per kilowatt hour? Is it saving or generating? Readiness for heat pumps. Heat pumps are a great way of transferring to the electrical grid, which will enable us to use that renewable energy, that zero carbon energy. But heat pumps work at low temperatures. They might need oversized radiators. They need energy efficiency measures. How far do we need to go to enable that transition to an electrical grid? Fuel poverty. Is that perhaps the driving factor in order to insulate people's homes so they can afford to heat them? And finally, some of the other things I touched on earlier is poor quality housing and energy efficient homes have a strong correlation with poor health outcomes. So how far do we need to go in terms of our retrofit in order to get to those tipping points where that starts to turn around? So we haven't got all the answers to these questions yet, but there are a few around. So let's just look at a couple just to finish off. So first of all, this is again some work we've done with Letty, and I found this really interesting. This gives you the space heating demand distribution across the UK housing stock. And you can see that we're sitting at around about 120 kilowatt hours per metre squared median, and that the Enefit and Passive House are right up the other end, 25, 30, all the way to 15 for a new build Passive House. So that's where we are, and that's the scope of where we could get to with a fully fledged deep retrofit across all the housing stock. Another way of looking at this is from the National Grid's future energy scenarios, a Sankey diagram. And what it shows you is that kind of picture I painted, which is in 2050, we've got all these renewable energy sources on the left-hand side through the electricity grid, driving heat pumps in our and perhaps direct electric in our buildings. And you can see that residential there is at 177. Our current usage is 480 terawatt hours. So the amount of energy we currently used in buildings is 480 terawatt hours. We've got to get down to 177 for that diagram to work, i.e. for the amount we generate to balance with what we use. And what the National Grid tell us is that that means that we need to reduce our heating and hot water demand per home for an average of 12.5 where we are today, down to around about 3.2 for the consumer transformation or 7.1 for the system transformation. So there's a different scenarios that they've modeled. And what that looks like is there's our 12.5. That's the current new build 8.6. Those are the two scenarios. That's where an Enefit sits. That's the Passive House new build, and that's the Passive House new build with an air source heat pump, where we get an even better impact. So you can see that actually to get down to the sort of levels that the scenarios that they're painting require, need pretty deep retrofit. And some buildings we're not going to get to for tenure reasons or whatever. So actually with those that we can get to, we need to go to pretty much the deep retrofit level approaching anything. And where are those buildings? So this is my second to final slide. And this is another Sankey diagram, but this time it's not the numbers of the housing stock. I've translated this into the potential for energy saving in the housing stock. And again, now you can see it switched around. The biggest chunk in terms of building form is in our semi-detached, but we've also got lots of cavity insulated buildings, which we need to perhaps go further with to get to this deep retrofit. So how do we deal with those? And of course, we still got a big chunk of solid uninsulated as well. So, you know, we perhaps need to think about legislation and policy to start targeting those specific areas. And I couldn't really put it better than the National Grid themselves, because this is just one scenario, the electrification. We think that's where we're going. There might be other options in the future, but wherever we go in the future, energy efficiency is a no regrets measure. So it makes everything easier, makes every option easier. Thank you very much. Stop sharing.
Thank you, John, and thank you, Joseph and David, for speaking. I'm Christina Gage, the RIS President. Sorry for being late today. I was meant to be chairing today's event, so I'm very sorry to be coming into this discussion at a late point, but I'm very pleased to have almost caught everything, so that's great. And thank you to Alex for introducing everything at the beginning, and I put him in the hot seat, so threw him in the deep end. So apologies for that, Alex. But I mean, it's fantastic that this is the second event on retrofit that the EAA have ran, and I think the more obviously we get into this discussion, the more detail that comes through, and I think the complexity of it comes through, but also the approaches that are becoming available. You know, like Joseph said, actually the documentation is becoming little bit more rounded. It's not as fragmented as it was, let's say, even 5 years ago. So I think that progress is being made. There's a lot of questions that have come through on the chat, and a few of them have been answered. I'm just going to run through a couple that I think might be useful in case other people haven't seen them. Sorry, I've got them on my phone here. So just to make sure that everyone's seen the answers. So the first one was to David, and it sounds like this is set up to deal with work on social housing. How does it work with individual houses for private clients? So this is regarding the Retrofit Coordinator Diploma. And David, I think you mentioned that it is more geared towards social housing, but I didn't know whether you wanted to say a little bit more about maybe where it's heading or the potential that it has.
Okay. I think it probably refers to PAS 2035 more generally being aimed at social housing. And it's interesting because there's a very piecemeal approach to the application of this standard. It's required under certain funding regimes. So under the energy company obligation, it's mandatory by the end of June. The UK government has just launched something called the Social Housing Decarbonisation Fund, which is quite a large-scale innovation competition in social housing that requires full PAS compliance. And then this Green Home Grant, I mean, I don't know even know what to say about that, but anyway, part of it does require it and part of it doesn't require it. So it's very confusing. So it's not designed with social housing in mind. The PAS certainly isn't. It's designed with all housing in mind. It's just that the government is told the industry it needs to reform itself, and it will reform itself around PAS 2035, whichever sector you're working in. But they only have the levers to control, social housing and the eco sort of sector, the fuel poverty sector. So it's just as relevant. I mean, I made a mistake in my presentation. I apologise. I should have taught you about the medium-term retrofit plans, the creation of a bespoke plan for every property on the back of one of those assessments, it was a total error on my part, sorry. Creating one of those plans for any property is a fundamental first step of any retrofit project, whether it's social housing or private housing.
I think that's really helpful. And I think, it has to be holistic. It has to be all building types. And I think that there always has to be a testing bed, and social housing seems to be that, possibly because of the client body, the funding and the policy that's available there. It's kind of a testing, allows things to be tested essentially, which is helpful, and hopefully has helped to drive things forward as well. There's actually one more question for you, David, as well. So whilst you're here essentially, is there equivalent PAS for non-residential sectors and similar diploma courses available within the Retrofit Academy?
No, right. So yes and no, but yes.
Sorry.
No, that's all right. So yes, there is something called PAS 2038, which is a new British standard being developed for non-domestic property. No, we don't offer any training on that at the moment because it doesn't exist, but we absolutely will do as and when I think it's about a year away from being published, so all the working groups and all that stuff is working its way through. What I would say, and there's certainly that group have already discussed the fact that there's an awful lot of non-domestic property which is very similar to domestic property, and therefore the expectation is it will be dealt with in a very similar way to the domestic stuff. So, large scale schools and hospitals and all that stuff, that's different. We recognise that. It's lots in common for that long tail.
It's great that that's happening, though. I think, again, it's moving in that right direction, and things will come with time. Joseph, this might be a bit of a difficult question, and it's from me, actually. So I hope, again, not putting you in the hot seat. I feel that, especially in Scotland, when we're going through the building control, the statutory process, there's a heavy reliance on manufacturer systems. And I suppose what everyone's presented today is there's a lot of documentation available. You need to choose what's right for the building. There needs to be a specific approach. It's not a one size fits all necessarily, although there are trends. And I suppose, do you see a point where we're going to overcome that manufacturer-led kind of system approach and really move to that holistic professional assessment where building control are going to come with us. So they don't necessarily need a certified system that works as a whole, but actually it's a bit more of a kit apart approach and very much professional led, which is obviously where the retrofit coordinator and the design integration roles are going. Do you feel that that'll happen? Sorry, difficult question.
That's a really difficult question. Yeah, I mean, you can see where the kit of parts comes from, because people want confidence, and somebody says this lot works together. I mean, I would say the role of the building design professional, even if you decide to go with that installation company and this system, even within that system, well, first of all, is it appropriate or not? So when you go with that system, you're using all parts of it. I mean, generally that's a broadly good idea because they're designed to work together. But is it the right system at all? Is the designer's responsibility to say yay or nay, to steer the client? And everyone, regards us as being the disinterested, objective person in the mix. Everyone else has got a position, but we're meant to be saying we need to do the right thing. It needs to be compliant, and it needs to serve the greater good and to serve the client and so on. But the other thing is, even within that system that you've now selected, well, there's different installation values in there. There could often sometimes be subsystems within it. And then there's also, how is that applied? And does it apply to every part, every wall, every roof, every whatever? So there's still lots of room for maneuver in there. But I do think, talking about my analogy of the designer sometimes going into space and floating above the earth and isn't even aware of this, yeah, there can be a danger where somebody says, I'm going to use, to take let's say external wall installation, I'm going to use this fixing system and that insulation board and that adhesive and this render and this mesh and this other finish, and I'm just going to throw it all together because I'm so great, or it just has to work or whatever. And that's dangerous. And it's also stupid, because those systems, they have been designed, millions of euros have gone in to make those things. But having said all of that, we also always need to be aware that insulation suppliers, or any supplier of any material, wants to sell. And yeah, most of them are reasonably ethical people, but they still want to sell, and they're under pressure to sell with, in terms of their pay package or their bonus or all the different things, structures that we put in place in society. And they're expecting us to put limits on them, and sometimes we don't put enough limits. And I've seen cases where very large installation companies have said this is, let's say, the U value, and there's no condensation risk or whatever in the page, in the printout, and there's like 7 or 8 pages, and in 0.6 text on page 5, it says in section 134, we're assuming no thermal ridging, we're assuming this, we're assuming that. And actually, they may have been given documentation that showed those things, showed thermal bridging, showed fixings, showed whatever. So, for generations, we've been asking them to do things where actually, if we opened the document, like I said earlier on, and looked at page 4, you'd see the scope tells you that's the wrong thing to do. So we're all, in many cases, many of us are complicit, and that's uncomfortable to say. They could really catch on their game a little bit, but we could actually educate ourselves better and actually take a little bit more due diligence too. And the whole industry needs to up its game somewhat. I think we really are in the process of that, and it's not comfortable. But I think there's so much that's going on that's positive, like I said, since around 2011 or so, and maybe even more so now. But it's a difficult story, and you need to be aware. We each need to be aware of our role in that.
I think that's a very good point. And I think things like the WUFI and the Glazer method, for example, are a really good example. So if certain companies and certain systems are using the Glazer, it's actually pushing them to use a slightly more in-depth or holistic system as well. It's a whole industry change. So I think it is an uncomfortable place, you're right. And it's hard, because I think sometimes people at the forefront of trying to push these things come up against statutory barriers, because the manufacturer's information might not be there yet, or they're trying to use a company that's up and coming, and they haven't all got the certifications. I think we are in kind of transition, but it definitely is going in the right direction, which is a good thing.
Christine, if I could just say there, not everyone wants to use the kind of technical software such as Phpp or WUFI, but they do need to know enough. Everyone in this industry, every design professional needs to know enough in the industry that, let's say, when if they have a limitation, that they go to the right person for the knowledge, and that they take that seriously. And equally, if, let's say, an installation supplier says, well, I'm going to give you a hydrothermal risk assessment, and here it is 20 minutes later, and it's been pushed out of software using Glazer, but it's a solid wall, you know, the designer needs to know at least, I'm sorry, that's not an admissible, that's not an acceptable assessment. If you want me to specify your product, you need to give me a proper within scope assessment. So I'm rejecting this. And now you're beginning to push back, and now the manufacturer is beginning to realize, oh, that used to be acceptable. No one needs to challenge me. I actually now need to change my tack. So you're beginning to educate those people. So I think we need to engage that way too. And that includes, like I said, the non-technical people who do need to know those at least broad, you know, big picture kind of understandings.
And I think it's that knowledge, it's that confidence for that pushback. You know, I think that's the threshold we're at, which is exciting. And obviously, I hope events like this help to facilitate that as well, which is fantastic. I have a question for John as well. I realize we're slightly over time, but I don't want to overlook any questions. John, you might have responded a little bit to this in the chat, but regarding the Enefit, are there any existing buildings where it really wouldn't be feasible to try and apply the standards, or are there any very good examples that are at that limit essentially?
Yeah, so I think this is what I was trying to get across with the heating demand method versus the component method. So those factors which are out with your control, which are going to make the building less efficient, are your form factor. So you might have a single story, like let's take a bungalow, the example I used. That's going to make it more difficult, and your orientation. So you might have lots of north facing glazing, for example, and that's going to make it more difficult. So those two things together, plus your thermal bridging. So you might have some really appalling thermal bridging, which there's a limit to what you can do about it. Those three things together might mean that getting to the 20 or the 25 or the 30 kilowatt hour criteria for passive house is, I wouldn't say impossible, but it would be prohibitively expensive. You know, you can always get there if you go far enough, but it might just be in terms of cost and return, it's just not worth it in certain situations. And those are the situations where you drop back to the component method, the elemental method. And what that will do is that, you know, you might end up with a space heating demand of 35, 40, something like that in certain situations, which means it doesn't meet the criteria. But what you have done is you upgraded all parts of the fabric to a very good standard, which means you'll still have a very comfortable and, for what it is, a very efficient building. So that's the way I do it. I wouldn't say it's this building or that building. I'd say if those criteria are against you, then you can drop back to the component method.
I think that's really helpful. And I think, yeah, you're right. That ceiling is always going to come into play. And I suppose there will always be examples maybe where that isn't prohibitive, and, you know, it can be implemented. But, you know, what I suppose in terms of sustainability as well and overuse, it's finding that balance between building and, you know, the use of materials as well is so important. And it's striking that going forward. I think it's just, you know, one last thing I wanted to mention is David and I last year, as part of the RIS convention, actually managed to get an audience with a Scottish Government cross-party group on how all of this kind of, you know, is kind of implemented in Scotland. I feel that we're a little bit behind, if I'm honest, and actually it's something that the RIS are trying to really drive in order to get a kind of a Scottish framework set up for how this is going to be implemented. And I know that it's crazy times at the moment and attention is elsewhere, but the programme for government looks a lot at technology still. And I think there's a big investment pocket for technology. And I do not wish to be negative about that. I think it is a key factor in this conversation, but it's, you know, we can't solely rely on the electrical grid with the housing condition in the way that it is, for example, you know, I think we all probably know that. So I think the first port of call has to be retrofit, has to be lowering that energy demand in order for the grid to be able to cope, and also in order to make those renewable products work most efficiently. And I suppose, do you have any, throwing it open to all three, do you have any words of advice, you know, that we can take forward to Scottish Government and how we push this forward in terms of the importance for Scotland, especially with the climate, fuel poverty, and all the parameters to consider? Don't know who wants to go in first. John, you're on my screen, so I'll throw you in there.
So I think this is kind of what I was trying to get at towards the end of my presentation, which is that if you ask one question, you might get the wrong answer. So if you ask the question, what's the quickest way or the easiest way to decarbonize, then you end up with lots of heat pumps and maybe not a huge amount of energy efficiency, just enough energy efficiency to make heat pumps work. If you ask how do we eliminate fuel poverty, you get a different answer. If you ask how can we reduce the load on our health services by providing healthy buildings, you get a different answer. So I actually think it's all of those together make a blended argument. And it's also the cost of the nation issue as well, which I think is really underplayed, because people, it really frustrates me when people say, oh, so what's the payback on that bit of insulation? That's a really poor way of assessing the actual value of putting that piece of insulation in. Yes, it makes sense to the homeowner, because that's how much it's going to reduce their bills. But actually, in the big picture, that kilowatt hour or the kilowatt hour you haven't saved has to be paid for elsewhere, and it's probably going to be more expensive. And I think that those arguments all together make a compelling argument that the levels of energy efficiency we need to achieve are actually quite deep, and they will have significant broader benefits across the whole community in different ways.
Sorry, I'll limit my answer just to the standard, the question of standards, if I may. And for what it's worth, Christian, I don't think Scotland's behind at all. You've actually got significantly more funding pro rata to the number of buildings you have.
Very true.
Going into retrofit than we do in England. It's just the COVID response has been a bit more high profile down here, that's all. Now, with the standard, we obviously think PAS 2035 is a very good standard. We've talked to the Scottish Government or officials about implementing it. I think there are slightly political reasons why they don't want to do that. I don't think it's got anything to do with a standard. I think it's a desire to have a standard that is Scottish, and that's understandable. But hopefully, if and when that does come out, it won't be a total reinvention of the wheel, because a lot of the hard work's already been done, I would like to think. So I think, and I've not heard much about that for 6 months now. So it seems to be drifting a bit, and perhaps a bit more pressure needs to be applied.
Yeah, definitely. Well said. And Greg Monroe in the comments is actually saying about, the change in building standards as well. It's kind of policy across the board that needs to change to help us with this. And I think, there was momentum to get there, but, we have stalled a little bit. And I think the conversation, we do have a lot of expertise in Scotland, David. I didn't mean to put Scotland down there in terms of where we are with this. I think it's more from a government and a policy level, so that it really affects the whole nation. It's not a niche operation in terms of a group of people really driving this forward. It actually becomes mainstream, and I think that's where we need to get to, and we're not quite there yet. But I appreciate Greg's comment in the chat about driving this forward in terms of building regulations, and it's very apt as well. Joseph, I don't know whether you want to come in with a closing comment on that, on how we can push this forward as an organisation.
Gosh, I was deep answering various people there, so I felt the question was in good hands. I think doing exactly what you're doing. I don't get asked that often by the RAAI, the Royal Institute of Architects of Ireland, to do this kind of talk. I've rarely seen, and they're very good people, but I've rarely seen the president of the RAAI chair a session like this. So fair play. And I think Alex is coming from even like the local Edinburgh chapter, if that's the right kind of language. Pardon me, I'm not as familiar. So I mean, you're showing innovation, you're driving standards, you're bringing good people together, you're sharing. And what else can we do? There was a question there earlier on from Joanna Weymouth, if that's the right surname. That there is a question as who are the right people to do the upskilling? Do we have the time? And I think one, maybe if I could say something positive, one lesson maybe from COVID-19 is that we can all get on and do an awful lot more online than we're used to thinking about. And in fact, when the entire planet has to do it, there isn't an excuse. And actually some of this kind of stuff, the technical kind of upskilling, is in a funny way suited to online learning. Actually, learning software can actually be quite a satisfactory experience, not a compromised experience. Particularly where you're a building design professional and your robustness, your professionalism, your maturity is all there. You know what you're about, you know the general context, and now you're learning these specific upskilling aspects. That actually can be done really well online. And that opens up the entire world, So here I am calling from Dublin, and it's not a problem. So maybe that's a good lesson that there's a silver cloud or silver lining in the current not so nice cloud, and we can all benefit from it, and it can help us do things quicker, better, higher quality.
That's a very good point. And I think in terms of where we are, current situation, pandemic, economy, actually upskilling is even more important than ever. And I think you're right, that door is wide open. So hopefully, we can start to take advantage of that as a profession as well. And I think that kind of brings me on to the last, my last point that I want to make, if this, unless the speakers have anything else they want to bring up, and that's again the funded Retrofit Coordinator diploma that was mentioned, and the deadline that's tomorrow at midnight. There was a link in the chat. I don't know whether everyone saw that, and also it's on the Retrofit Academy website, I believe. So, take advantage of that if you can. You may be flooded with applications, but hopefully that's okay. And it was great to have everyone here tonight. I think it's such a critical topic, and I think this kind of series of events that's building actually starts to lead us into more detail, and just helps people to build their knowledge. So it's the steps that we were just talking about before moving to that kind of holistic understanding and confidence to push back. So let's hope this has helped with that. But I'd like to say a huge thank you to the EAA, Edinburgh Architectural Association, for hosting tonight's event, and everyone that's in attendance. I hope everyone is okay. It's pretty rubbish at the moment. There's no getting away from that, and I hope everyone's families and friends are well and healthy. So thoughts go out to everyone here tonight, and thank you very much to the speakers for taking the time to put together tonight's presentation and pack so much information into one event. Absolutely fantastic. So thank you very much, everyone, and stay safe.
Welcome. You too.
Thank you. Bye.
Thank you. It's a pleasure.